All right, hello Kia, hello. So I'm gonna have you up because you are the designated guest of honor. Hello Kia.
Hello, sir. Hello, sir.
I hope you're good. I hope you're well. Had a good day. All right, awesome. So I saw your message about specifically you said financial maths and you said depreciation. Eh?
Yes,
So what did you guys start it? Did you start that topic today or did you start it? I don't know. Have you been doing it?
we did. We started doing it on no yesterday.
Oh,
Yesterday.
yesterday. Okay. All right. So that means you pretty much understand what depreciation is, and you guys have probably done some problems as well using the formulas and all of that.
Yes, but I still don't understand that much.
Oh, okay. All right. So what I'm gonna do is I'm just gonna explain what depreciation is, and then we'll look at a few problems. But I think it's important to understand what it is, and then we'll take it from there. So just hang on a sec. All right. So very quickly, yeah, I guess this would be beneficial to like grade 9 students that are doing IEB. And yeah, because I have an IEB grade 9 learner that I'm actually assisting with financial maths, and specifically we're looking at depreciation. So yeah, I hope sort of like the loose understanding that I'm sure you do have. I'm sure you've seen like how, for instance, when you buy a car, maybe your mother or someone that you know has bought a car, and what happens is that car over a period of time, like in 2 years time, if like let's say if I bought that a particular car today for, I don't know, let's just say it's 200,000. In 2 years time, that car will not have that same value. You know, it will not increase in value, but rather it will decrease in value, right? So in other words, the car loses its value. Why? Because as you use it, you know, then yeah, there's a term that's usually used that's called wear and tear. Because as you use something, it sort of like becomes more and more outdated, if you will. All right. And the
Yes.
equipment becomes outdated. If you're speaking about the car will become outdated. I'm sure if I don't know if there's like a particular range of cars that you actually like. Like, is there a particular car that you like?
No,
No, you
no.
don't. Okay, so you're not much of a car lover.
Yes.
So nothing catches your eye at all. Like nothing at all. You've never seen a car and be like, yo, one day I wish I can drive that car in the future.
No.
Sure. Okay. All right. I guess you'll be working on your feet then in the next few years. Yeah. But anyways, um, but yeah. So here's the thing. Here, if you look at what I've just written, there's something that I've written down here. It's like in many situations, equipment can lose its value over a given period of time. All right. So yeah, and then it says like motor vehicles or computers, they lose their value over time, and that is because of this concept of wear and tear. Because the more you use something, it becomes outdated, okay, or it may be because of becoming outdated. All right. So we say that equipment has depreciated in value over time. So depreciation is simply a loss in the value of a particular item or equipment. All right. So I
Yes.
hope that the term depreciation makes sense to you. losing value of something over time, especially in Breisky, of course, because we are talking about bought items here. Okay. So, so there's something else that I want to mention here. There's a term here that we refer to as the book value. The book value is simply this: the value of a particular item or equipment at a given time after depreciation has taken place. So the minute something loses its value, let's say I have this car, like I said, I bought it for 200,000. In 2 years' time, you're going to find that I cannot sell that car at 200,000. I can sell that, I actually sell that car at a much more lower price, maybe 100K, right? Because what has happened is that that car's book value has changed. That car's value has changed. So its book value, meaning the value of that particular car at a given time after it has lost its value, has taken place. We refer to that amount, that new amount, as the book value. So sometimes in these problems that they give you, instead of saying what is the depreciated amount, they may say in the question, what is the book value of that item? And oftentimes students do not know what the term book value means. So it's important that you know what the term book value means so that when they do ask in a particular question what a book value is, then you know it is the final amount of that car after a certain period of time when that car's value has gone down or whatever item they may be referring to. Okay, so that's what the term book value. It's the value of equipment at a given time after depreciation has taken place. All right. That's what this term means, book value. Then there's this term as well, scrap value. Scrap, scrap, scrap. I'm sure when you hear the word scrap, I don't know if you're thinking of anything when you hear the word scrap.
Something old.
Yeah, exactly. Yeah. There's even like, I'm sure, I don't know if you've ever heard of a scrapyard, but a scrapyard is like basically after car accidents have taken place, you'll actually find that there's like all the remains, like the cars that basically were in an accident, you'll actually find them there in the scrapyard. And what they do is they dismantle the cars sometimes and they take certain parts so that they can reuse them like for other purposes. So basically, the scrap value is the book value of that particular equipment at the end of its useful life. It's almost as if like that's when that particular item can no longer be used anymore. So whatever that value of that equipment is, we refer to it as the scrap value when we can no longer use that item anymore. All right, at the end of its useful life. So does that make sense?
Yes.
Okay, sweet. Then I'm sure you know then these two formulas. I think I saw these two formulas in your book one. I think your book one or book two, the one that you had sent. There are two types of depreciation. I'm sure you know. There's the what we call the straight line depreciation, or sometimes they refer to it as the linear depreciation. Linear and straight line basically mean the same thing. So if they say linear depreciation or straight line depreciation, they basically talking about that sort of depreciation. Okay. There's a formula for linear depreciation, and that is A is equal to P brackets 1 minus small letter I, small letter n, close brackets.
Wait, sir, but it's compound. Oh, sorry. Ish.
Sorry?
This is for
Linear.
for interest. No,
Linear.
like, but it's interest. It's interest, like it's simple interest. Is it simple
So
interest?
simple interest, this is the formula. A is equal to P brackets 1 plus I n close brackets.
Yes, I was
So the
asking like that formula, is it like for simple interest?
Yeah, for simple interest, there's a plus in the mix. But for linear or straight line depreciation, there's no plus, there's a minus.
Oh.
Okay. So sometimes they refer to this as simple depreciation or linear depreciation or straight line depreciation. Okay. So I'm glad that you're mentioning that. The simple interest formula is 1 plus IN. And the keyword here is interest. Okay. Meaning increase. Whereas here we are talking about depreciation. All right. So the formula, the difference in the formula is that it's A is equal to P brackets 1 minus I times N. Okay.
Yes.
So there's a minus sign for straight line depreciation or what they refer to as linear depreciation. Okay.
Yes.
So are we together? Are you with
Yes.
me?
Yes.
All right. Then what does the A mean? The A stands for the book value or the scrap value. Okay. Obviously, it will depend. Okay. Because remember, what did we say the book value is? We said it's the value of the equipment at a given time after. So it's after depreciation has taken place, which means this only happens after a few years have actually passed by. Okay. The
It's but
new,
so for
go
scrap
ahead.
value,
Yeah.
it's isn't it the same thing as book value because it's like after. It's also
Yes, yes,
after.
yes. Yes, it's also after, but remember, scrap value specifically, it's at the end of its useful life when we no longer need to use that particular item anymore. All right.
Yes.
Yeah. So yes, these are both after a few years have passed. Okay. But the difference is your scrap value is a book value, but it's just that it's of that particular equipment at the end of its useful life when we no longer have to use it anymore. All right.
Yes.
So it's just further down. Okay, so like I said, that's why we are saying here, A can either be book value or scrap value. So it will all depend on the particular question that is being asked. If they say book value, then of course we know they're talking about A. If in the question they say scrap value, we know that they are talking about A. Okay. All right. Then what does P stand for? Present value. All right.
Yes.
Okay. I, small letter I, that's what we call the depreciation rate. All right. And it's usually in decimal form, the depreciation rate. Okay. So it is obviously given to us in the problem as a percentage, but usually what we do is we convert that depreciation rate by saying R over 100. We take the percentage because R stands for percentage. We divide it by 100 so that we can get the depreciation rate as a decimal number. Does that make sense?
Yes.
Yeah. Then N stands for time period, specifically in years.
Oh.
Okay.
Yes.
Yeah. So are we sure that we understand the different variables of the formula? A, book cost scrap value. P, our present value. I, which is the depreciation rate as a decimal. N, the time period in years.
Yes. I understand it.
Okay. Do you have any questions at all whatsoever?
No, I don't have.
Okay. Then, since I said to you that this type of depreciation is called linear or straight line depreciation, it means that we can actually represent the we can represent this sort of depreciation in graphical form. Okay, like your x-axis can be the time in years, and then of course I'm sure you can see if, let's say, at the beginning I bought this car for a certain amount of money, that would represent a very high price, of course.
Yeah.
But then what happens as the years go by? You can see this item is doing what? It is in value, it is decreasing as I increase the number of years. So as I increase the number of years, my value, my item, if you, let's say this was a representation of the car being bought for 200,000. This is at the beginning of my purchase of the car. At year one, there's a decrease. Year two, it further decreases. Year three, it further decreases. Does that make sense?
Yes.
Yeah. So this is just a graphical representation of this linear or straight line depreciation. All right. So graphically, this is what you would see. The time in years, as the years go by, this item that I have purchased, it simply loses its value. Okay.
Yes.
Okay, then we can move on to the next formula, which is compound, or sometimes they refer to it as the reducing balance method. So compound depreciation. Okay. Sometimes referred to as the reducing balance, reducing balance. So this is just another term that also means compound depreciation. This is the formula for compound depreciation. Does this look familiar?
Yes.
Here?
Yes, it
Okay, I
does.
hope so because all right. And you see that there is a minus, okay?
Mm.
Did you
Yes.
guys do compound interest by any chance?
Yes, we did.
All right, because you would probably know that like simple interest, the compound interest formula also kind of looks like the formula that we just looked at, but it has what instead of a minus?
A plus sign.
It has a plus. Yeah. Okay. So this is something you need to take note of. So the simple interest and compound interest have a plus, okay, compound interest, okay,
Yes.
whereas straight line depreciation and compound depreciation have a subtraction sign, okay. We're together.
Oh, yes, sir.
Okay, then with the graphical representation is what you would see. Instead of a straight depreciation, it's sort of like a curve, all right. Yeah, but it also just shows that as the number of years passes by, what you are finding is that the value decreases, all right, as the years go by, all right? Just graphically, bit different. It's not a straight line, right? Like the straight line linear depreciation, rather it is a decreasing curve, okay? All right. Now, the A still stands for the same thing. It's the book or the scrap value. P is the present value. I is the depreciation rate. And then N is the time period in years. Okay.
So how
Sophia, I
does
don't know if you have. Yes.
no, I wanted to ask how does compound depreciation decrease since it's not a straight line?
How does it decrease? All right. So
Yes.
here we are. Do you see this graphical representation of compound
Yes.
depreciation?
Yes.
Yeah. So again, I'm sure you can see the direction of this line. So basically, 1,000, that's the car, right? So that is the price of the car at the beginning as you have just purchased it. The next year, year one, what are you finding? All right. If this is the value of the, if this y-axis represents values, obviously from 0 we are going up, but what are you finding with this line? This line is decreasing. Okay.
Yes.
It- At year 1, what are you going to
Yes.
find? The car is going to be less than what it was at the beginning. Year 2, what do you find? You see what I mean? It's decreasing as well. The price of that item is decreasing as the years go by. So from the beginning when we purchased it, obviously it's brand spanking new. After year 1, it's getting used up. Year 2, it's getting used up, and you can see that the value for 200,000, definitely, we're not talking about the same amount. If we are here, we're not talking about, this is a less amount than the 200,000. Here, this is definitely a less amount than the, way less amount than the 200,000. Okay. So whether it's a straight line or a curve, if it's depreciation, then we are losing value. Okay. There's going to be loss of value for that particular item.
But but why? I still don't
So
understand
the so
how
the,
come this one curves, but they both decreasing.
wait, how come?
I don't understand how this one compound depreciation decreases, yeah, like no, decreases like in a curve like that, but simple depreciation like decreases in a straight line even though they're both decreasing.
Okay. So the thing is, so here for simple interest, the way, let me just say this. This one decreases at a constant rate. Okay.
Yes.
At a constant rate. And when I mean by constant rate, is that you will find that it will decrease by the same amount every year. So for instance, if let's say for instance it decreases in the first year by 200 rand, the next year it will decrease by 200 rand. The next year it will decrease by 200 rand. So it decreases at a constant rate, hence the straight line. Okay. Yeah. But for this one, it does not decrease at a constant rate. Okay. And that's the difference
So
between linear and compound.
compound it decreases a lot each time.
Yes, compound
So
decreases
compound,
a lot each time. Yes, very true. Beautifully said. You
yeah,
couldn't have
I
said
think
it better.
I understand.
Yeah, you couldn't have said it better. It decreases a lot every time. This is kind of like the same idea when it comes to, like, when you were looking at interest, simple interest versus compound interest. What you found is that simple interest, what happens is that it increases, like your amount of money, it will increase every time. But for your compound interest, yay, your compound interest, it would grow at an exponential. And the way that simple and compound interest at the beginning grow, it's like the same. But the thing is, compound interest just continues to increase at a very exponential rate. So it increases by a whole lot more than with simple interest. Okay. So so just as the increase here for compound interest is exponential, then of course here with the decay or with the decrease in the amount of the value of the item, like you said, it will decrease definitely by a whole lot more. Okay. So I think we got the same page then. Okay. Some people in the comment section can be batty. Oh, you prepared. Are you guys writing?
Yes.
Oh, you're writing what? Geo tomorrow?
Yes.
Oh, okay. All right. And is this like a classmate? Simply Zozo.
It's a friend.
Ah, funny, funny. Oh, a friend. Okay. All right. Let's. Okay. I want us to then look at like some specific problems around these two methods. So let's look maybe at an example. Okay. So question says calculate. Okay, let's just say. So we are told that Joshua wants to sell his car, but he wants to do it in 5 years' time. To sell his car, but he wants to do it in 5 years' time. We are told the rate of depreciation, is 14% per annum. And the car's current value is 60,000. Calculate the book value. Calculate the book value. Firstly, if we are looking at line depreciation, and then B, if we are looking at the same situation under the compound depreciation. This question and then answering it, Kia. That's how I'm going to be able to establish that. Hi, you are good. Joshua, as you've seen here, wants to sell his car in 5 years' time. All right.
Yes.
The rate of depreciation is 14% per annum, and the car's current value is 60,000. So we need to calculate the book value using straight line depreciation. So let's start with the straight line. Do first, we read obviously the statement and ensure that we have understood what is in the statement. Then after that, what then can we do?
Use the formula.
We can
Use the formula.
use the formula. But before we use the formula, wouldn't it be important to identify first all the variables that the formula will need?
Yes.
Yes. So let's do that then. Let's identify the variables that the formula will need.
A is equals to 60,000.
So A is equal to 60,000, yes.
And P is equals to, no, we don't know what P is yet.
Okay. So I'm just writing what you are saying.
Oh.
So first and foremost, you said A is equal to 60,000.
No, so I'm wrong. Wait, it's P. P is equals to, yeah, P is equals to 60,000, and in A we don't know.
All right. Okay. So P is equal to 60,000.
Yes.
Okay. Okay. Why are you saying P is equal to 60,000? It's because in the statement, what did you see that made you say that?
Because it said current value.
Exactly. Current value is 60,000. And we know that current value means our present value. So yes, P is 60,000. Then What else?
Um, I is equal to I is. Wait, can I please see the statement again?
So there it is. Joshua wants to
Oh,
sell his car in 5 years' time. The rate of depreciation is 14% per annum, and car's current value 60,000.
so I is equal to um 0.14.
Awesome. I is equal to, so you took the 14%, you divided by 100, it's 0.14. Definitely. I agree. Thank you.
And
What else
N
do we
is
need?
equal N is equal to 5 years.
Okay, n is equal to 5. Yes. What else?
We don't know what A is. We still have to find it.
We don't know what A is, so we put a question mark.
Yes.
Okay, you think we've collected all the information we need?
Mm, yes, yes.
Okay, yeah, we do, hey. Yeah. Pain. What does that spell? Pain. What does that spell?
P
Pain spells?
penny.
Pain.
Pain.
What does this read as?
Pain. Pain.
Pain. Isn't financial maths a pain?
Oh, it is.
Okay, now we can write down the real formula, which is A is equal to, for straight line depreciation, A is equal to?
um P. No, A is equals to P.
Yes, yes,
Um, in brackets 1 minus I. No, 1 minus the
okay,
interest rate, and then
yes,
times um time N.
thank you. Okay, now we can substitute. In the place of P, we write,
60,000.
yes, 1 minus. In the place of I, we write,
0.14.
and then in the place of N, we write.
5.
Then we grab our calculator and it does the magic, and then we write the answer.
Yes. It's 60,000 times. Our answer is um it's 18,000.
Hey, beautiful. Second question, answering the same way. Now we need to find the same but for compound depreciation. So we have our collected information, no problem. But this time around, what formula would we use?
Um oh, the compound depreciation formula.
Yes, which is?
A is equals to P
Mm-hmm.
in
Yes.
brackets 1 minus
Mm-hmm.
I close brackets with the, is it exponent of, yeah, N.
Yeah, good job. Good job. Definitely exponent of n. You are spot on. After the bracket, the exponent n, definitely. Then we substitute. What we need to substitute in the place of P, I, and N. Do you
Oh,
remember what
so
P was?
we're using the same formula. I mean the same statement.
Yeah, because here it's saying calculate the book value if it's straight line depreciation, and then they want us to actually do it with compound depreciation as well.
So P is going to be 60,000. Okay.
Yeah,
And then 1 minus I 0.14
yeah,
close brackets with
thank you.
the exponent of 5.
Awesome. All that is left is our beautiful work on the calculator so that we can get the value.
And our answer is 28,225.
28,225. If you round that off for me to two decimal places, what is it?
After, you mean after the number that comes after the comma or before?
The number that comes after the comma. But I'm saying round it off to two decimal places.
You, I think it's 50. I think it's 52.
So what do you have after the comma in your actual calculator?
It's
It's
62.
28225, comma.
62.
Awesome. Good job. 62. Yeah, that you are correct. 100% correct. Two decimal places, comma 62. Okay. All right. That was foundational. So that is foundational to the problems that we do. But remember now that finding A is just the introductory part. In other questions, you'll be given maybe the N, the A, the I, and then they'll ask you to find P. Or you'll be given the I, the A, the P, and you'll be asked to find the N. All right.
Yes.
Yeah. So, yeah, there's a myriad of other problems that you
So
can have there.
when we're looking for the I or the N or the P, I can use the formulas that I know from how to find those ones, like from simple inches or compound inches.
Yes, but remember now that there's no plus sign as per your simple interest and your compound interest formulas. There's a minus sign. Yeah, so you need to just take that into consideration.
Yes.
Okay, so I don't know under the IEB banner if like your teachers actually give you actual formulas. Because for instance, in under CAPS, what learners are usually asked to do is they are asked to write down the original formula, substitute into the formula, and then try and make N, I, or P the subject of the formula. But I saw, for instance, I saw you. I think I saw in some of the other things that you were doing that you guys are actually given the formulas that
Yes.
for N, for I, and for P. That's true, right?
No, but no, those ones I just figured out how to do them on my own. But they didn't. No, they only give us